a week or two if you're a champion stair climber, or 12 hours if you're on a motorcycle. A tower to space would be very different from a space elevator. A space elevator would be about 100,000 kilometers tall, while a tower to space would only need to be 100 kilometers. As Ethan mentions, it would need to be pressurized, with an airlock every few miles. A stairway to space one would have about 500,000 steps. World champion stair climbers, too, like Christian Riedel or Kristen Fry, can travel roughly a Mount Everest height in a day. Riedel set the half-day record last October by climbing 13,145.65 meters in 12 hours. At that pace, taking the other 12 hours to rest, eat, and sleep each day, it would take him a little over a week to reach the top. Climbing all those stairs would burn calories, which would mean you'd need to carry food. It turns out that the most efficient food you can carry, in terms of calories per pound, is butter, which is why Arctic explorers carry so much of it. Suppose your backpack holds 9 liters. Climbing 10 stairs burns about a calorie, which means climbing all the way up to space will burn about 72,000 calories. If you fill your backpack with butter, it will hold almost enough calories to get you to the top. However, since it would take you weeks to climb all those stairs, you'd also need your normal dietary allowance of 2,000 calories, 3 sticks of butter, per day. Combining that with the 72,000 calories just from climbing the stairs, and you probably need to upgrade to a more serious 16-liter backpack. If you fill that backpack with butter, it will let you carry around 110,000 calories. 3, which should be enough to get you to the top if you're really dedicated. If you don't want to eat 35 pounds of butter, 4, you could try getting to the top by motorcycle. Based on how quickly this rider ascends 45 stairs, a motorcycle could conceivably make it to the top in a day. Okay, so you got to the top. Now what? Getting up to space isn't that hard. After all, the hard part is getting into orbit, and the tower doesn't help you very much with that. So what else could you do? Michael Longwet Higgins was a research professor at the University of Cambridge and an expert in fluid dynamics, bubbles, and unusual types of waves. 5, 6. In 1953, Dr. Longwet Higgins was shown by a colleague an interesting toy which had recently appeared on the market. This toy, Slinky, had some unusual properties. The professor immediately set to work analyzing it and wrote up his results in a paper. Dr. Longwet Higgins first determined through mathematical modeling that the rate at which the Slinky descends steps should depend only on the properties of the spring itself, and not the size or shape of the stairs. He and his colleague conducted a series of experiments on 5 different flights of stairs of various dimensions in Trinity College, Cambridge. Their conclusion: the Slinky descended at a constant rate of about 0.8 seconds per step. 7, 8. Dr. Longwet Higgins determined that the Slinky quickly reached a constant descent rate after first few steps. This tells us that if you place a Slinky, similar to his, at top of the stairway to space and gave it just the right nudge, it would make it back to the bottom in just over 5 days. Or, to put that in more appetizing units,